Okay, so far we considered only single component system, and now we need to move on to multi-component system, because most of the systems in chemical engineering are multi-component. There is hardly any single component system. Okay, so consider a heterogeneous system of pi phases. Pi could be any number, and these phases are alpha, beta, gamma, delta, etc. till pi. This is general derivation we are doing, so we are looking at this, but generally we have maximum 2 or 3 phases. Can't have more than 3 phases, but general derivation hai, so we are considering it many number of phases. And if there are components C, 1, 2, 3, etc. up to C, components can be many. There can be sometimes 10 components in a system. You will see systems which have 10 components. So components can be many, but phases normally will be 2 or 3. But derivation is for many phases, pi phases. So if I take mu subscript I superscript k, it's a chemical potential of component I in k phase. So subscript is component and superscript is a phase. Now suppose small amounts of components are transferred from one phase to another with the system in equilibrium at constant temperature and pressure. We always talk about constant temperature and pressure systems because that's what we encounter in our chemical engineering processes. So since the system is closed, we know the equilibrium criteria, which says that dG is equal to 0. Okay. So free energy change in a multi-component system equation is given. We have derived this equation before. dG is equal to VdP minus SCT plus summation of mu I dNi. Right? This is what derivation we have done long back. So at constant temperature and pressure, dt is equal to 0 and dP is equal to 0. And what we'll get is equation 3, which is dG is equal to summation of mu I dNi. Okay, so substitute equation 3 in equation 1, and what we'll get is dG is equal to summation of mu I dNi equal to 0. Okay, any questions on equation 4? Okay, so suppose we have d and I, d subscript I superscript k has increased the number of moles of component I in phase k. So subscript is component, superscript is phase. So equation 3 becomes, we have to do summation over all components and over all phases. So summation from I equal to 1 to C components and summation from k equal to pi alpha to pi phases. So summation for I all components and summation for all phases. Mu subscript I superscript k dn subscript I superscript k. So we'll have this summation over all components, all phases, and that is what equation 5 is. Any questions on equation 5? So expand equation 5.
Sir, repeat.
Repeat what? What did
Sir,
you
5. Equation.
Equation 5.
Equation.
Equation 4 is dG, that is change in free energy of the system, is equal to summation of mu I dNi equal to 0. That is general equation which you derived, right? But now we have multi-component system, so we have many components and we have many phases, right? So we have to do summation over all components and all phases. This one dG equal to summation of mu I dNi was not considered for multi-phase systems. It was only considering components. That's why it was superscript I only. There was no subscript I only, no superscript. Now we have to introduce all phases also. So summation has to be for all components in all phases. And the change in free energy for all components in all phases is equal to 0. Is that understood?
Yes, sir.
So that's why we are doing double summation. Summation for components from I equal to 1 to C components, and then summation for all phases k equal to alpha to pi phases, and then we write mu subscript I, that is component I in k phase superscript k, and d and I sub component I in k phase. that is equal to 0, equation 5. समझ में आया?
Yes, sir.
Okay, so we expand equation 5 and write for each phase and each component, right? So first we write for component 1 in all phases, then component 2 in all phases, then all the way till component C in all phases. That's what we are doing in equation 6. That is alpha mu subscript I in alpha phase, mu subscript 1 in alpha phase, dn1 in alpha phase, plus mu subscript 1, that is component 1 in beta, dn1 in beta, like that till all phases pi. So mu1 superscript pi, dn1 superscript pi. So this is for component 1 in all phases. Then similarly for component 2 in all phases, mu subscript 2 for alpha phase, dn2 superscript alpha, plus mu subscript 2 superscript beta, dn2 superscript beta. So component 1 alpha phase, component 2 alpha phase, component 2 beta phase up to pi phase. And this is for second part is for second component in all phases. Similarly, we can write for component 3, 4, 5, 6 till C, and we'll get mu subscript C component for alpha phase, dn subscript C for alpha phase, plus mu subscript C for beta phase, dnc for beta phase, up to mu subscript C for pi phase and dnc for pi phase. So this is for component C. So all components and all phases are included now, and this summation has to be equal to 0 because that is what is equation 5 or equation 4. Any doubts on equation 6? Okay, so if there are no doubts, we are considering a closed system. We always consider closed system. We are not considering open systems. So mass balance will say that there is no change in number of moles of component 1, right? Itna bhi hai. We are not taking a reaction here. We are considering only mass transfer. Reaction will consider in unit 5 and 6. So for the time being, consider only mass transfer between phases, between various phases. So there is going to be no change in number of moles of component 1. It will be constant. That is material balance seen in PC. If there is no reaction, the number of moles will remain constant. Okay. So in that case, what we can say is we can write dn1 in alpha phase plus dn1 in beta phase plus up to dn1 in pi phase equal to 0. So number of moles, total number of moles in the system is, change in number of moles in the system is 0. Moles are constant, that means there is no change in moles. Suppose number of moles in alpha phase increase, so it has to decrease somewhere else, right? In beta phase or gamma phase or delta phase, somewhere it has to decrease. But total change is going to be 0. Any questions on this part, first part? The simple material balance which we have done in PC. There is no change in number of moles. So dn of component 1 is equal to 0 for all phases. Similarly, we can write for second component for all phases. dn2 for alpha phase plus dn2 for beta phase plus up to dn2 for pi phase, that is equal to 0. So no change in number of moles, total number of moles of component 1 or component 2 in all the phases. You combine all the phases, there is no change in number of moles. You can write for many components, 3, 4, 5, etc. up to component C. So dn for component C in alpha phase plus dn for component C in beta phase up to dn for component C in pi phase. So this for component C, again there is no change in total number of moles in the system. Any doubts on questions on equation 7? Okay. If there are no questions, then if you look at equation 6 and equation 7, when will equation 6 and equation 7 be satisfied?
For closed system only, no?
For
closed system, no?
Yeah, closed system only. You're talking about closed systems. You're not talking about open systems now. You're talking about closed systems only. So if you look at equation 6, it is mu1 alpha, dn1 alpha, etc., up to everything, up to all components in all phases, that is equal to total is equal to 0. Right? So for all components and all phases, mu1 or mu I superscript k, dnr superscript k is equal to 0. And from equation 7, we know that number of moles of component 1 or change in number of moles of component 1 is equal to 0. Similarly, change in number of moles of component 2 is 0 up to C. So equation 7 will be satisfied only if you look at this mu1 alpha is equal to mu1 beta is equal to mu2 pi, mu1 pi. Only if they are equal, then this equation 7 will be satisfied. Then we can take this out, mu1, and then in the bracket we have dn1 alpha plus dn1 beta plus dn1 gamma up to d11 pi. Similarly, if mu2 is equal, mu2 alpha is equal to mu2 beta is equal to mu2 pi, then only this equation 7 will be satisfied up to component C. Only if these mu's are same in all the phases, equation 7 is going to be satisfied. That's what we have written in equation 8. Any questions on equation 8? How we got equation 8?
Yes, sir.
समझ में आया ना? Because this dn1 alpha plus dn1 beta plus dn1 pi has to be equal to 0. So we can, if you take out mu1 alpha, and if we say that mu1 alpha is equal to mu1 beta is equal to mu1 pi, then only we can take it out common, and we get mu1 alpha into bracket dn1 alpha plus dn1 beta plus dn1 gamma plus dn1 pi यहाँ आ जाएगा. और फिर अगेन mu2 alpha कॉमन निकाला, mu2 निकाला कॉमन, bracket dn2 alpha plus dn2 beta plus dn2 pi, and similarly mu c निकाला बाहर, तो dnc alpha plus dnc beta plus dnc pi is equal to 0 आएगा. वो 0 हो जाएगा तो ओवरऑल इक्वेशन 6 0 हो जाएगा. So equation 6 and 7 will be satisfied only if all the chemical potentials of each component are same in all the phases. So mu1 alpha is equal to mu1 beta is equal to mu1 pi. Similarly, mu2 alpha is equal to mu2 beta is equal to mu2 pi. And for component C, mu C alpha is equal to mu C beta is equal to mu C pi. So all the chemical potentials have to be equal for each component in all the phases. If you take component 1, chemical potential is same in all the phases. If you take component 2, chemical potential is same in all the phases. If you take component C, then chemical potential is same in all the phases. Any questions on this equation 8? Okay, if there are no questions, so what we can say is for a system in equilibrium with respect to mass transfer, we are considering only mass transfer, no reactions so far. The driving force of mass transfer must have same value for each component in all phases. Or we are seeing chemical potential is the driving force for mass transfer. So criteria of thermodynamic equilibrium in a closed heterogeneous system, multi-component system, is the temperature and pressure has to be equal and equality of chemical potential. We have seen what you call first two conditions we have seen temperature and pressure equality before also for heat transfer and fluid flow, and third one we are adding is mu I alpha is equal to mu I beta is equal to mu I pi for component I equal to 1 to C. So this is our criteria of thermodynamic equilibrium in a heterogeneous multi-component system. Equation 9. Any questions on equation 9? No? Okay. So we can simplify this and say if you substitute mu I is equal to RTLN Fi bar plus C by definition, what you'll get is Fi bar alpha is equal to Fi bar beta is equal to Fi bar pi. So it means fugacity of component I in solution in alpha phase is equal to fugacity of component I in solution in beta phase is equal to fugacity of component I in solution in pi phase. It has to be equal for all components. So equation 10 is alternative criteria of equilibrium.
Yes, sir.
Any questions on equation 9 and 10? So exam में कभी कभी आता है derive the criteria of equilibrium for a multi-component system. So you have to derive this equation 9 and 10. Okay. If there are no questions, then we'll move to the next topic. फेज रूल आप लोगों को पढ़ा होगा, राइट? केमिस्ट्री में पढ़ा है फेज रूल?
Yes, sir.
So what is phase rule? Does anybody remember?
F equal to C minus P plus 2.
F is equal to C
Minus pi
P
plus 2.
Okay, good. So we are going to do the derivation. Derivation किया क्या इसका कभी? Evident
नहीं
derivation?
सर.
नहीं ना, ठीक है. So we are going to do the derivation. How we get this phase rule? Okay. Now this is always for intensive properties. It is not for extensive properties. Remember that. Phase rule is always for intensive property. What is intensive property? Example? Of intensive properties.
Specific volume.
Huh? What was it? You're right. Repeat it.
Specific volume.
Specific volume. Yes, that is also. Okay. For example, ये पहले हमने किया है यूनिट 1 में. We started with intensive and extensive properties, right? And I gave you a lot of examples of intensive and extensive properties. To just repeat that, recall rather. किसी को याद नहीं है इंटेंसिव प्रॉपर्टीज क्या होता है? अभिषेक कुमार.
Yes, sir.
What is the intensive property? Example of intensive property.
Those are depends on quantity.
Depends on quantity. Is that correct? Who can confirm or deny?
No, sir.
It doesn't depend upon quantity of the
Does not depend on quantity. उल्टा बोल रहे हो अभिषेक कुमार. You have to do a lot of catching up. Attendance कम है, आपका catching up भी नहीं किया है. Test है अभी आपका, right? Intensive
करूंगा sir.
properties do not depend on mass or quantity of material. So what are the examples of intensive property? Abhishek.
Sir, density.
Density, okay, good. Or
temperature, pressure.
Temperature, pressure,
pressure. Agreed. Temperature, pressure is the most common
refractive
intensive
index.
property. And extensive property का example?
Volume.
Volume.
Mass.
Volume, mass. It depends on quantity, right? Anything which depends on quantity is extensive. That is mass, volume. Okay, so let's see. Phase rule is for intensive properties only. So temperature, pressure वगैरह रहेगा. Most common is temperature, pressure. Okay. So number of, what it says is number of intensive properties that can be varied without changing the number of phases or number of components in any phase. Okay. Let us see, F is equal to degrees of freedom. That's what we define as degrees of freedom. C is number of components and P is number of phases. यहाँ पर P लिया मैंने, pi भी ले सकते हैं, no problem. Anything is fine. So consider heterogeneous system of C components and P phases. So the composition of a phase with C components is determined by specifying C minus 1 concentration terms. Why is that? Why do you have to specify? अगर 3 component है तो 2 का composition या तो हो जाता है क्या काम? Is that enough? Consider 2 components, right? Ethanol, water. Suppose I give composition of ethanol only. Is that enough?
No, sir.
Yes, sir.
कौन बोला no? No किसने बोला था?
Sir,
ठीक है,
Vaibhav.
yes. वैभव, क्यों no? क्यों no? Why no?
पता नहीं समझ में नहीं आया।
हाँ? क्या?
समझ में नहीं आया सर।
समझ में नहीं आया. Okay, I said ethanol water system लिया मैंने, and if I say it is 50% ethanol, is that enough to give the composition of the solution? उससे solution composition समझ में आता है क्या पूरा? Water कितना समझ में आता है क्या उसमें? वैभव,
हाँ
if I
सर।
say it's a ethanol water solution and I say that ethanol is 50%, बोल परसेंट बोलो, मास परसेंट बोलो, कुछ भी बोलो, I say that ethanol is 50%, तो उससे water का composition समझ में आता है कितना है?
Yes sir. 50%.
कितना होगा? 50%, right?
50%.
That we have seen. Because if you take summation of mole fractions, if I say mole percent, suppose I take XA plus XB for 2 components is equal to 1 आएगा, right? कभी भी. Number of mole, total of mole fractions is always equal to 1. So if I specify for 1 component, the second is already specified by default. Mass percent में 100 हो जाएगा, mole percent में 1 हो जाएगा. Summation of mole fractions is equal to 1 and summation of mass percent is equal to 100. So I need to specify only C minus 1 concentration terms for C components, right? So last component is already specified because I know summation of mole fraction is equal to 1, or if it is mass percentage, summation of mass percentage is always equal to 100. ये समझ में आया लोगों को? Why it is C minus 1 terms चाहिए, C
Yes.
components. Okay. So number of concentration variables required to define for P phases. अगर P एक phase है, suppose हमने इतना water लिया, एक phase लिया water, right? Suppose there are P phases or 2 phases, तो double करना पड़ेगा, right? Liquid and vapor लिया, तो वेपर का भी हमको एक कंपोनेंट का डिफाइन पड़ेगा concentration. Suppose I take ethanol water, liquid and vapor in equilibrium. I have to specify vapor composition and liquid composition, right? So I have to specify P into C minus 1 variables, right? समझ में आया ये? दो फेज रहा तो 2 into C minus 1, that means 2 into 1. बाइनरी सिस्टम के लिए कंपोनेंट बढ़ेगा तो वेरिएबल्स भी बढ़ जाएगा. And we have always said that we always need to specify temperature and pressure. That is important. That is the intensive property we need to always specify. जैसे हमने इतना वाटर लिया, टेम्परेचर क्या है उसका? 25 डिग्री सेंटीग्रेड है कि 40 डिग्री सेंटीग्रेड है, 50 डिग्री सेंटीग्रेड स्पेसिफाई करना पड़ेगा. प्रेशर कितना है? सी लेवल पे कर रहे हैं कि माउंटेन पे कर रहे हैं? एवरेज पे क्या रहेगा उसका प्रेशर, वेपर प्रेशर कितना रहेगा? वेपर प्रेशर एवरेज पर वाटर का. ये भी एग्जांपल दिया था मैंने आप लोगों को. Why we cannot make tea at on a mountain or say Mount Everest? हाइट ज़्यादा हुआ तो. क्यों नहीं बना सकते चाय हम वहाँ पर? Any guesses? Yeah, I have given you the example before also. PC में दिया है, thermo में दिया है. Why we cannot make tea at Mount Everest at such height?
सर क्योंकि जैसे हाइट बढ़ती है तो प्रेशर बढ़ता जाता है ना.
प्रेशर बढ़ता है. किसने बोला है?
एटमॉस्फेयर. सर देवेंद्र.
अरे यार, प्रेशर कम होता जाता है यार, उल्टा बोल रहे हो तुम.
हाँ.
प्रेशर कम होता जाता है. दैट्स व्हाई दे कैरी ऑक्सीजन सिलेंडर माउंट एवरेस्ट पर, because the atmospheric pressure is so low that oxygen is not enough for breathing. That's why they have to carry a oxygen cylinder with them for breathing purposes. That means the pressure is very very low. प्रेशर बहुत लो होगा तो क्या हो जाएगा? बॉइलिंग पॉइंट को
घट जाएगा.
बहुत कम हो जाएगा, राइट? So if you take a height of Mount Everest and find out what is the boiling point of water, you'll know what is the boiling point, and that I'll leave it as an assignment for you, homework for you. Find out what is the boiling point of water on Mount Everest. ठीक है? Okay, so specifying temperature and pressure is important. That is required. So total number of variables कितना हो जाएगा? P into C minus 1 plus 2. Right? Composition के लिए P into C minus 1 plus temperature and pressure के लिए 2. So इतना variables हमारा हो गया to specify the system. समझ में आया equation 1? Any doubts on equation 1? Okay. There are no doubts. Let's move. So, but the system is in thermodynamic equilibrium. That means it obeys the criteria of equilibrium for multi-component system, which we just saw. That means the principle of equal chemical potential in all phases. Right? अगर कोई भी system लिया हमारा तो chemical potential same रहना चाहिए for each component in all the phases. That means the concentrations are not independent. Liquid का हमारा concentration पता है तो vapor का हम निकाल सकते हैं because chemical potential is same for water in the liquid and vapor phase. Okay. So for any component there exist P minus 1 equations connecting concentrations in P phases, right? Concentration जो रहेगा liquid and vapor, right? If I know liquid and vapor, अगर binary system है और flow phase है, right? तो the P minus 1 equations connecting concentration, जैसे mu1 in alpha phase, in mu1 in liquid phase equal to mu1 in vapor phase, right? You can write that. If you take binary system and you take two phases, then you know that mu1 in alpha phase equal to mu2 in beta phase. बराबर है, ये अभी हमने देखा डेरिवेशन, राइट? अगर दो फेज है तो एक इक्वेशन रहेगा, तीन फेज है तो दो इक्वेशन रहेगा. Like that, that's what we are saying. For any component, there exists P minus 1 phases equations connecting concentration in P phases. समझ में आया ये?
सर वो mu1 और is equal to mu1 रहना चाहिए ना.
वही है, सेम है ना. mu1, oh sorry, you're right. It is not mu2. It is mu1. mu1 in alpha phase equal to mu1 in beta phase. बराबर. If there are two phases, then there is at least one equation connecting the chemical potentials in the two phases. This is a constraint. ये हमारा criteria of equilibrium है, right? So if there are P phases, then we have P minus 1 equations connecting the concentrations in P phases. Okay? And number of components we know is C. So number of independent equations, ये जो equations है, this is equation, right? ये equation कितना हो जाएगा? C into P minus 1. Depending on number of components, अभी हमारा number of components 2 है, तो 2 हो जाएगा, right? ये equation into 2. If there are C components, it's C into P minus 1. इतना independent equations है हमारे because of thermodynamics or equilibrium. ठीक है? Any questions on equation 2? Okay, if there are no questions, then we define as degrees of freedom is number of variables that are independent, which is nothing but variables that must be defined or fixed to define the system completely. That's the definition of degrees of freedom. And this is equal to total number of variables जितना हमने define किया था कि इतना specify करना चाहिए minus total number of independent equations which you already have, right? ये जो हमारा ये दिया है, right? ये question हमारा है, इतना हम specify नहीं कर सकते, right? So we can say equation equation 1 minus equation 2. 2 minus 3 नहीं होगा. It is 1 minus 2. ठीक है. सो जितना वेरिएबल्स हमको डिफाइन करना चाहिए और जितना कंस्टेंट्स है वो माइनस करना पड़ेगा हमारे को. सो व्हाट वी गेट इज वी सब्स्टिट्यूट फॉर इक्वेशन 1 and 2. इक्वेशन 1 इज p into c minus 1 plus 2. This part is equation 1 and this part is equation 2. राइट. इसको ओपन किया हमने तो पी सी कैंसिल हो जाएगा एंड व्हाट वी गेट इज f इज इक्वल टू c plus 2 minus p or c minus p plus 2. You can write it anyway. And that is our phase rule. ठीक है. Any questions on how we derived this equation 3? Okay. If there are no questions, ये भी कभी कभी एग्जाम में आता है डेरिवेशन ऑफ फेज रूल. You should be able to derive this equation.
Sir,
Yeah.
the number of variables which are independent वो एक बार फिर से बोलो.
Number of variables that are not independent. ये constraints है basically. ये जो हमने लिखा है ये this part is basically number of equations. राइट. ये इक्वेशंस हमारा ऑलरेडी डिफाइन करते हैं. अगर μ1 फॉर फेज 1 पता है मेरे को, दैट मीन्स आई नो μ1 फॉर फेज 2 आल्सो, बराबर, फ्रॉम दिस क्राइटेरिया ऑफ इक्विलिब्रियम. सो आई डोंट नीड टू स्पेसिफाई μ1 फॉर फेज 2. एक पता चल गया तो मेरे को दूसरा पता चल जाएगा. अगर 3 फेज रहेगा तो मेरे को तीनों पता चल जाएगा. एक से एक पता है तो दूसरा 2 भी पता चल जाएगा. राइट. दैट्स व्हाट वी सेड. नंबर ऑफ वेरिएबल्स दैट आर नॉट इंडिपेंडेंट, दैट मीन्स नंबर ऑफ इक्वेशंस. जितना इक्वेशंस है उतना कंस्ट्रेंट्स है हमारा. उतना स्पेसिफाई किया तो ज़्यादा स्पेसिफाई हो जाएगा सिस्टम. इट इज ओवर स्पेसिफाइड सिस्टम. समझा गया. ये हमारे वेरिएबल्स डिफाइन करना है. वी हैव टू डिफाइन दीज नंबर ऑफ वेरिएबल्स टू डिफाइन अ सिस्टम कंप्लीटली, राइट. बट देयर आर कंस्ट्रेंट्स, देयर आर इक्वेशंस व्हिच आर ऑलरेडी अवेलेबल व्हिच कोरिलेट फेज 1 with phase 2, which is given by number of equations, right. This is c into p minus 1. तो उतना माइनस करना पड़ेगा. Then we have number of independent variables which we need to specify to fix the system.
Yes, sir.
Any other questions?
सर वो इक्वेशन 2 है ना, वो एक बार उसका डेरिवेशन रिपीट कर सकते हो क्या? वो नहीं समझे.
Okay, so if there are 2 phases and 2 components, right. तो अगर इक्वेशन ऑफ क्राइटेरिया ऑफ इक्विलिब्रियम क्या देखा था हमने, μ1 in phase 1 is equal to μ1 in phase 2, बराबर. That is a constraint. That is an equation which already specifies. So if I know μ1 in phase 1, I also know μ1 in phase 2, बराबर. And we have seen chemical potential is the driving force for concentration और mass transfer, right. तो हमारा मास ट्रांसफर जो concentration है यहाँ पर μ1 से फिक्स किया था. So I know already a constraint की अगर दो कंपोनेंट है तो मेरे पास एक इक्वेशन ऑलरेडी है फॉर अ बाइनरी सिस्टम, बराबर. यहाँ पर सिमिलरली आई कैन राइट फॉर कंपोनेंट 2 mu2 for alpha phase equal to mu2 for beta phase, right? तो मेरे पास दो इक्वेशन मिल गया बाइनरी सिस्टम के लिए, दो कंपोनेंट के लिए, राइट? So components are 2, phases are 2 minus 1 or into p minus 1, 2 minus 1, that is equal to 2. Right? That is what I am writing, c into p minus 1. So for a two component binary system, I get two equations which restrict the number of variables I can define. क्योंकि already defined है मेरे लिए, I don't have to specify more things. अगर ज़्यादा specify किया तो over specify हो जाता problem. Like if you say y is equal to mx plus c, right? You just need y and x values, two variables. If you specify 3, then it is over specified. Similarly here also, if you specify more variables, then it's over specified system. You cannot fix the system. So we have to say कि इतना constraints है ये, इतना हम specify नहीं कर सकते, define नहीं कर सकते. Automatically ये fix हो जाता है because of thermodynamics or phase equilibrium. समझ में आया equation 2?
Yes, sir.
Yes, sir.
Okay. So finally equation 3 में किसी को doubt है कुछ, किसी को? We are just doing 1 minus 2, number of variables minus number of equations connecting those variables, right? Basically, that's what it is. Equations are connecting those variables. So mu1 in phase 1 is equal to mu1 in phase 2. Mu2 in phase 1 is equal to mu2 in phase 2. It's connecting those variables. So ultimately defined है. mu1 in phase 1 पता है तो mu1 in phase 2 भी पता है मेरे को. mu2 in phase 1 पता है तो mu2 in phase 2 भी पता है मेरे को. I don't need to specify separately mu1 in phase 2. I don't need to specify separately mu2 in phase 2. It's already known. That's why we are saying कि इतना हमको माइनस करना पड़ेगा क्योंकि ऑलरेडी हमको पता है, बिकॉज इक्वेशन से हमारे को मिल जाता है वो. ओके, एनी क्वेश्चंस ऑन इक्वेशन 3? ओके, so sometimes you get problems also on this phase equilibrium पे. So if it is one component system and single phase, तो कितना डिग्री ऑफ फ्रीडम हो जाएगा?
2.
Right. So just substitute number of component, number of phases. Right. Two component system, two phases. Two components, two phases क्या हो जाएगा?
2.
2. Yeah. So you can just substitute and find out, right? And single component, two phase system. Water and steam.
Plus 1.
Yes. So just substitution है और कुछ नहीं है इसमें. Steam tables, and that's why if you look at steam tables, you always specify either temperature or pressure. दोनों स्पेसिफाई करने की कभी जरूरत नहीं रहती. स्टीम टेबल कभी यूज किया किसी ने? स्टीम टेबल नहीं यूज किया कभी क्या? So go and check steam tables. यूजफुल रहता है. आई थिंक थर्मो 1 में आता है, आपका शायद हुआ नहीं है. बट स्टीम टेबल्स में ऑलवेज स्पेसिफाई स्टीम का प्रेशर और टेम्परेचर. वी डोंट नीड टू स्पेसिफाई बोथ टेम्परेचर एंड प्रेशर because it is a single component system, two phase system, right? So water and steam, degree of freedom is only 1. Three phase system लिया, ice, hot, water and steam, तो क्या हो जाएगा? Single component, three phase system.
Zero हो जाएगा.
0, right? So that means for triple point it is already fixed, 273 Kelvin and 618 kPa. Ice, water, steam जो रहता है in equilibrium, that is already fixed. You don't need to specify anything. Okay, binary mixture of liquid and equilibrium matrix vapor. So two components, liquid and vapor. That means two components, two phases. क्या देखा था हमने? कितना आएगा डिग्री ऑफ फ्रीडम?
2.
2, right? So we need to specify two things. Either we specify two intensive properties, temperature and pressure, or we specify temperature and composition, or we specify pressure and composition. any two intensive properties we need to specify to fix a binary system in VLE, vapor liquid equilibrium. Okay, any questions on phase rule for non-reacting systems? Okay, if there is no question, then let's move to next topic, Duham's theorem. I don't know whether you can finish it. Let's see. होगा तो अच्छी बात है, नहीं तो कंटिन्यू करेंगे कल. So phase rule we have seen is for intensive properties. But if I want to fix, suppose I say water, right? वाटर का हमने कितने देखा सिंगल कंपोनेंट सिस्टम में? प्योर वाटर लिया हमने, राइट? सिंगल कंपोनेंट सिंगल फेज. तो टू इंटेंसिव प्रॉपर्टीज देने का. सो टेम्परेचर एंड प्रेशर विल स्पेसिफाई बिकॉज यू सीन कि वाटर का टेम्परेचर बॉइलिंग पॉइंट चेंज हो जाता है, राइट? रेस्ट पर. सो प्रेशर इज इम्पॉर्टेंट, टेम्परेचर इज इम्पॉर्टेंट, बोथ आर इम्पॉर्टेंट. But if I want to specify the complete system, I need to also say that how much is the quantity of water, right? अगर water लिया मैंने, temperature pressure दे दिया, but quantity नहीं बताया, 1 kg है कि 1 ग्राम है कि 10 ग्राम है कि 100 ग्राम है. So it is not completely defined system. Intensive properties defined है, that is according to phase rule. But extensive properties भी define करना पड़ता है to completely define a system. And that is what Duham's theorem talks about, right? The state of system is completely determined only when we have intensive plus extensive properties defined. Quantity of water भी define करना जरूरी है, 1 kg लिया कि 1 टन लिया कि कितना लिया, right? Extensive properties we have seen, mass है, volume है, जो भी है. So in addition to phase rule for intensive properties, mass of each phase should be defined to define the state of the system completely. अगर 2 phase लिया तो mass पता रहना चाहिए, liquid का कितना है, vapor का कितना है. Then we can say completely defined system है, right? So total number of variables क्या हो जाएगा? ये हमने देखा था पहले, ये इंटेंसिव के लिए देखा था. बट नाउ वी नीड टू स्पेसिफाई कि ईच फेज में कितना मास है, राइट? सो अगर p फेजेस है तो p ऐड हो जाएगा नंबर ऑफ वेरिएबल्स में. अगर एक फेज है तो वाटर लिया सिंपल हमने, तो कितना kg वाटर है, एक वेरिएबल ऐड किया हमने. अगर 2 फेज है तो दोनों फेज का मास ऐड करना पड़ेगा, तो 2 ऐड हो जाएगा. अगर p फेज है, 3 फेज है, तो तीनों का ऐड करना पड़ेगा. सो देन total number of variables will be intensive variables हमने देखा था p into c minus 1 plus 2 previous derivation में, plus number of phases. ठीक है, equation 1 is okay. Okay. So for a closed system, material balance can be written for each component, right? हमने देखा था. So we get additional c equations. Material balance for each component we can write, right? For a closed system, C1 component 1 in phase 1 plus component 2 in phase 2, you can write that is equal to, or DC change in number of components, suppose, okay, so change in mass of component 1 in phase 1 plus change in mass of component 2 in phase 2 is equal to 0. बराबर, total is equal to 0. So we can write material balance equations. अगर पता है इनपुट हमारे को, तो आउटपुट भी पता है हमारे को. टोटल नंबर ऑफ इक्वेशंस विल बी, पहले का जो था ये वाला c इंटू पी माइनस 1 पहले वाला था, प्लस c कंपोनेंट्स के लिए c मटेरियल बैलेंस इक्वेशन वी कैन राइट. मटेरियल बैलेंस इज कनेक्टिंग मास, राइट? तो मास अगर पता है हमारे को इनपुट का, तो आउटपुट का हमको पता है. सो टोटल डिग्रीज ऑफ फ्रीडम विल बी, पहले किया था हमने नंबर ऑफ वेरिएबल्स माइनस नंबर ऑफ इक्वेशंस. जैसे फेज रूल में किया था, यहाँ नंबर वेरिएबल्स चेंज हो गया, extensive number of equations change because we added extensive properties. So we can substitute equation 1 and 2 in this equation and we'll get, substitute किया इधर तो सब cancel हो जाता है, f is equal to 2. So equation 3 is called Duham's equation. Any questions on equation 3? Okay, there are no questions. That means you only need two independent variables to define the state completely. This is for MM. We just need two, or minimum two rather, not say only two. It's a minimum two. I should say minimum two. Okay. These two variables may be intensive or extensive. जैसे हमने देखा फेस रूल में sometimes we got degree of freedom equal to 0, right? यहाँ पर 2 आया, यहाँ पर 1 आया, right? यहाँ पर 2 आया, then यहाँ पर 0 आया, और यहाँ पर 2 आया. तो इंटेंसिव प्रॉपर्टीज के हिसाब से हमारे को पता चला कि समटाइम्स डिग्री ऑफ फ्रीडम इज 1, sometimes it is 0, sometimes it is 2. But Duham's theorem says if I want to completely specify the system, including intensive and extensive, then I need minimum of 2 variables. तो जहाँ पर 0 था वहाँ पर, जैसे यहाँ 0 था, right? In this case, I need to specify at least 2 extensive properties. Mass of ice या mass of water लेना पड़ेगा, then only I can fix mass of steam. जैसे ये था फेज इंटेंसिव प्रॉपर्टीज 1 था यहाँ पर स्टीम एंड वाटर के लिए. टेम्परेचर intensive properties are fixed, but extensive is not fixed, so I need to specify at least one more variable or mass of water or mass of steam to fix the complete system condition, including extensive and intensive. समझ में आया? Any questions? Any questions on this? Hello?
No, sir.
ठीक है. So we need minimum 2 variables. So Duham's theorem says for any closed system formed initially from given mass, right? You have to say initially from given mass to mass दिया initial दिया है, तो उसके हिसाब से the equilibrium state is completely defined when any 2 independent variables. Let's see for different systems. For f equal to 1, phase rule says intensive properties f equal to 1. At least one amount, we need to specify at least one variable. If we have any questions on this? Sir. Hello.
सर वो थोड़ा थोड़ा ये
Hello. Can you hear me?
यस सर.
थोड़ा ही समझ, क्या नहीं समझ? Very well.
Sir, your voice is not clear.
क्या बोल रहे हैं? हेलो.
आवाज नहीं आ रहा था, ब्रेक हो रहा था बीच में।
सर वॉइस वॉइस
ओके, वॉइस ब्रेक हो रहा था. कहाँ तक पहुंचे थे हम? क्या वॉइस ब्रेक हुआ?
सर वो एग्जांपल्स देखे ना अभी हमने।
एग्जाम्पल्स ना. डेरिवेशन समझ में आया? F equal to 2.
यस सर
ओके. सो डेरिवेशन अगर समझ में आया तो एग्जाम्पल में सिर्फ वही दिखाया मैंने कि सपोज F इज इक्वल टू 1. पहले देखा था हमने, राइट, फेज रूल में. F इज इक्वल टू 1 फॉर स्टीम वाटर सिस्टम, राइट. उसमें F इक्वल टू 1 दिया है इंटेंसिव प्रॉपर्टीज के लिए. बट टू कंप्लीटली डिफाइन दिस सिस्टम इंटेंसिव एंड एक्सटेंसिव वी नीड मिनिमम 2. दैट मीन्स एक एडिशनल वेरिएबल डिफाइन करना पड़ेगा विच कैन बी द मास ऑफ लिक्विड और वेपर. ओके. इंटेंसिव प्रॉपर्टीज के लिए 1 है, दैट इज ओके, दैट इज डिफाइनिंग द इंटेंसिव स्टेट ऑफ द सिस्टम. But if I want to define the complete state, including intensive and extensive, I need minimum of 2 variables to be defined. तो एक और वेरिएबल डिफाइन करना पड़ेगा, दैट कुड बी द अमाउंट ऑफ वाटर और वेपर. सो देन F इज इक्वल टू 2 हो जाएगा. समझा ये एग्जांपल F इक्वल टू 1 का?
यस सर।
सिमिलरली F इक्वल टू 0 लिया था हमने, राइट, बाय फेज रूल. जहाँ आता है स्टीम वाटर आइस सिस्टम, राइट, वहाँ पर इंटेंसिव प्रॉपर्टीज F इक्वल टू 0 है. दैट फिक्सेस, यू डोंट नीड टू स्पेसिफाई एनीथिंग. बट हमारे को एक्सटेंसिव स्टेट डिफाइन करने के लिए एटलीस्ट 2 वेरिएबल डिफाइन करना पड़ेगा विच कुड बी kg ऑफ वाटर, kg ऑफ आइस. अगर 2 ये फिक्स हो गया तो ऑटोमेटिकली स्टीम फिक्स हो जाएगा. दैट्स व्हाट दिस मीन्स. मिनिमम 2 चाहिए कम से कम. अगर 2 से कम है, अगर 2 है फेज रूल में, ठीक है, वी डोंट हैव टू स्पेसिफाई एनीथिंग. बट अगर फेज रूल से 2 से कम आ रहा है तो वी नीड टू स्पेसिफाई एटलीस्ट 1 और 2 extensive properties to completely define the system. समझ में आया अभी?
यस सर
Duham's theorem is relevant only when F is less than 2 for phase rule. अगर 2 आ गया, 3 आ गया, suppose we get 2 in phase rule, right? ये last next example है. F इक्वल टू 2 आया था, बाइनरी सिस्टम, इथेनॉल वाटर लिया था हमने. F इक्वल टू 2, तो देन वी डोंट टू स्पेसिफाई कि कितना क्वांटिटी ऑफ वाटर है, कितना क्वांटिटी ऑफ इथेनॉल है. दैट ऑलरेडी फिक्सेस इट, बिकॉज डुहेम्स थ्योरम से हमको सिर्फ 2 चाहिए, यानी मिनिमम 2 चाहिए. सॉरी, सिर्फ नहीं, मिनिमम 2 चाहिए. तो 2 ऑलरेडी हो गया, तो हमारे को और कुछ डिफाइन करने की जरूरत नहीं है. When F is equal to 1, we need to define 1 more. When F equal to 0, we need to define 2 more. So total should be minimum of 2. Is that clear?
यस सर
Stop here and we'll read. और टेस्ट का मैंने आपको बताया कि टेस्ट इज गोइंग टू बी सब्जेक्टिव, इट इज नॉट गोइंग टू बी ऑब्जेक्टिव. नो एमसी are going to have numericals and derivations and scan it or make a PDF of it and submit, and you will get maximum of 1 hour to complete this. There will be 2 questions. Simple रहेगा. I don't think you need more than half an hour to complete those 2 questions, but I'll give you 1 hour, no problem. But you have to submit on Google Classroom. Okay. Any questions or doubts on test? 31st of August at 2:45 p.m. Okay. So we'll stop the meeting.